Hi, welcome to this video. I'm yet another ham, and today I'm going to show you how to test the receiver sensitivity in this example on an Anytone 868. How is the receiver sensitivity measured, and which specifications do we find on the Anytone website? Here on the 868 specs, if you scroll down, you find the informations about the receiving part, and Anytone states a receiver sensitivity for the 12 dB ZNAT point, we come to that later, of smaller or equal to 0.25 microvolts if you have the receiver in the wideband setting, or 0.35 microvolts or less if you have the receiver in the narrowband setting. What is this ZNAT about? Well, ZNAT stands for signal to noise and distortion ratio, and once this ratio is 12 dB, then you have reached the RF level where the receiver sensitivity is given on. So the setup basically is you have a RF generator with a certain modulation, let's say 1 kilohertz, and a certain deviation, and there we have to see what Anytone states for wideband and narrowband, and then you increase the RF level up to this point where an audio analyzer which is connected to the receiver audio output gives you this 12 dB value. And as we can see here, the modulation limit is 5 kilohertz deviation for wideband and 2.5 kilohertz deviation for narrowband. And so we will take these settings on our RF generator to test the receiver sensitivity. Here is our device under test, and I will now go to the RF generator and signal analyzer. The RF generator is now set to 0.1 microvolts at 145.5 megahertz, 2.5 kilohertz deviation, and 1 kilohertz modulation. And now I will increase the RF level so that the signal generator above gives us 12 dB ZNAT, which you can see here at this point. Let's increase the RF level slowly but surely, and there you already can see that the ZNAT, which is quite jumpy, increases. And now we are at 0.14 microvolts, and we are still a little low. It's quite jumpy, but I think we still have readings below 12, sometimes over 12. That's a little difficult in this setup, but I think we are now well above 12 dB, and surprisingly we are way below the levels which are stated on the Anytone website, but they say it equal or less. So let's do this measurement again for the wideband settings. So let's switch the Anytone to wideband. We do this in the channel settings, go down until we see the bandwidth, and now we change to wide. Now the Anytone is set to wide, and of course we also have to set the signal generator deviation to 5 kilohertz, and we see that once we've done this, the ZNAT level got lower. And this is what I expect to be a fault on the Anytone website, because from my understanding, you need higher RF levels on the wideband setting. So I think they simply mixed up the values for narrow and wide. Now we increase the RF level. Oh, sorry, I have to switch to level. Now we increase the RF level again, and I think we already hit it on the spot with 0.17 microvolts, which is way below the specifications Anytone stated on their website. A little surprising, but yeah, this is what we've measured here so far. So if you found this video interesting, leave me a like. If you have suggestions for other videos, leave me a comment. Thanks for watching. 73.